Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. Error monitoring is provided by Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog.
I'm Paul Dix, and it's go time!
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. Welcome back, everybody. I guess it's been a long holiday break, but we are back to kick off the new year. This is episode number 64, and everybody's here this week. So Brian's on the show.
Howdy.
And Carlicia.
Happy New Year.
And we're kicking off the new year in style. We have a guest we've been wanting to get on for a long time, Paul Dix, who's CTO and founder of InfluxDB, and we all love InfluxDB.
Hey.
So for anybody who doesn't, who may not be familiar with you and Influx, do you want to give just a little bit of history and backstory?
Sure. So InfluxDB is an open source time series database that we created, which is written in Go, obviously. Started the company back in 2012, originally as a monitoring company, like a SaaS product to do real-time metrics and monitoring. And then over the course of 2013, realized that the infrastructure that we were building, the stuff that was the API that was written in Go, was actually more interesting. And then decided to bring that into the open source world as an open source database at first, mainly because I think developers, obviously, they like to build their stuff on top of open source. And that's the only way that I thought the project could be successful. And then over time, we raised more money. We did Y Combinator in 2013, and then we raised a Series A in 2014. And we basically, the thesis around it was, we didn't want to just build a database, but we wanted to build a set of other tools and basically a platform for working with time series data. In my mind, time series data is kind of a primitive that's very common amongst many, many different use cases. So you see it obviously in server and application monitoring, but you also see it in sensor data and all sorts of analytics use cases. So highlights on the company. We did, like I said, Y Combinator, Series A, Series B. We're probably about 70 people right now and maybe doubling that by the end of this year. So, yeah.
It's a lot of people. So can you explain to me in terms that I would understand, which might be difficult for you because I'm really slow, especially right after the holidays, how I could use Influx for something like my barbecue?
Which you've already done. I've seen the project.
Oh, you saw that, huh? Damn.
Yeah. So essentially, your barbecue has a number of sensors on it, right? I saw the temperature sensors and some other stuff. So you're able to just pull that sensor data into Influx, basically collect it. I'm not sure I can't remember what you used to collect that data and what those sensors actually are, what they're built on.
We're using MQTT right now.
Yeah, it's basically for that particular use case. We threw it together in a weekend. It was MQTT on Arduino-based hardware, and then Telegraph was picking that up and converting it into Influx, and then we displayed it on Grafana.
Right. Yeah. So that's very common, and I think the thing that's interesting is you have sensors on your barbecue. And I think that trend is actually only going to continue to accelerate. There are going to be more and more sensors out there in the world, and you're going to want to instrument that stuff. And a lot of times, you're going to throw the data away. What's the long-term value of, your barbecue data being collected every 10 seconds for the last 5 years? Probably minimal, but I think there are use cases within sensors specifically that are actually that will be very, very interesting.
So is Influx customized specifically for IoT use cases, or is that just a really nice fit to a more general product?
I think it's just a really nice fit to something general. So the data model of Influx is obviously you have a measurement name, you have a set of tags, which are key value pairs, where the values are strings. And those are basically like dimensions that you can slice and dice the data on. So a measurement name could be like, a grill temperature. And the tag information could be like not just one barbecue, but like many barbecues in many different locations for many different people that are owners or whatever. And then the actual series data, which is in Influx, it's what I call a field set, which is a field name, which would be just like a value or something else, or it could be like inner temperature, outer temperature, or like a temperature for each grill. And then the value itself, and then finally a timestamp. So it just so happens that that structure, that kind of schema, works really well for IoT data because it's very common that people who are tracking sensor data want to slice and dice the data along those lines. But it's also very common for server data as well, right? You want to see for this service, how are things performing? Or within this region, how are things doing? Or for this specific host. So I think the one other thing that is I think kind of unique with Influx and some of the other older time series solutions is that from day one, we wanted it to be useful, not just for what I call regular time series, which is, things, measurements collected at fixed intervals, so like once a minute, but also irregular time series, which are like event-driven series, right? So that could be the response time for an individual request to an API. It could be a trade in the stock market, or stuff like that, or a container spinning up or spinning down, that kind of stuff.
Hmm. So, as far as like Go usage goes, like, what's your experience been like building using Go? And you guys have done quite some interesting things, including creating like your own query language against it and things like that. Has it helped facilitate that? Do you have anything that you've kind of tripped up against?
Yeah, so our experience using Go has been fantastic. I remember looking at Go back in March of 2012 when 1.0 came out, and I thought it was interesting as a language. But at the time, well, I guess at the time I was writing primarily Scala code, which I was completely disenfranchised with at that point. But before that, I was a Ruby developer, so I was in the dynamic language camp, and then I switched to Scala, and then I was in the barren hellscape that is the JVM. And then looking at Go, what I appreciated was that the tooling was very simple, the really fast compile times. Whenever I had to do Scala stuff, it was just painful waiting for builds. So in 2012, in like the fall of 2012, when I was creating the like second version of the API for this SaaS monitoring application, originally I'd written that in Scala using Cassandra and Redis. So for this next cut, I wanted something that was like a single binary that could be deployed, and I thought like Go would be great for that. So I basically did a spike of writing like a basic time series API in Go, and then using LevelDB, which is a key value store that's actually written in C++ that came out of Google. But I did that really quickly to see like what kind of performance could I get out of this thing. And I saw that it was very, very good. So basically like fast forward to, through 2013 into basically late September or mid-September of 2013. And we had decided, like at this time, the company was me and two other people. And we had decided that, like, I had gotten back from a conference. I was like, okay, this product we're building isn't working, but I think the infrastructure is interesting, and I think this like time series thing is interesting. So let's do a spike on creating an open time series database based on our previous stuff and do it from scratch. And internally, we had this debate about what language we should be doing it in. And really, at that time, it was, okay, it's either going to be C, C++, or Go. Rust really wasn't an option at that time. I think it was pretty far from getting to any sort of 1.0 release, and none of us had any familiarity with it. And at the time, what I knew, because we already had experience in Go, is I knew we could be more productive faster using Go as a language versus C or C++. That's part of that is maybe a dig on how productive you can be in those languages, but also part of it is a dig on our lack of skills in them. If we were expert C++ programmers, I'm sure we would be, fairly productive, but we were familiar with Go. We knew we could be fast with it. Really, the concern that we had was, what about the garbage collector, right? It's a database. You're going to have massive heaps. What are we going to do about the GC? And my feeling was, there's like two paths here if we do it in Go and we have to deal with the GC. Path one is we perform the same sort of like crazy hacks that people in Hadoop land and Cassandra land and basically anybody writing databases and data stores in Java have been doing, which is essentially hide the data from the heap. Or we hope that the Go team, their development and what they're doing with the GC will front run where we are as a database. And thankfully, I think it's been a combination of both. One, like the Go team's improvements to the GC over the last, 4 years have just been crazy. It's been really insane. It's good. But then the other thing is I find that there's a lot of places in our code base that I've seen our developers over time see where they could optimize things so that we do fewer heap allocations, we keep stuff on the stack, and we get much, much better performance just because of the tooling that Go has to let you, introspect what's going on. They're only so basically my experience with Go has been overwhelmingly positive, and I've written about this a couple of times. I really do think that Go has a long lifetime ahead of it. And I do think that 5-10 years from now, it potentially has the possibility to overtake Java as the preferred, server-side programming language for like services. Our two biggest pain points over that time has been, which of course everybody is going to groan because I'm going to say things that everybody's heard a million times before, which is one, dependencies. Thankfully, it looks like that is finally starting to get addressed. And two, generics, which I'm not asking that they add generics to the language because I feel like there's a big win in not having them in terms of simplicity and readability and that kind of stuff. But we've definitely felt the pain in a couple of specific spots where generics would have been handy. And actually, Ben Johnson ended up writing this templating thing. So it's basically like this code generation thing that lets us hack around no generics, which is littered in our query engine code right now.
I think that's
sorry. Let me
Carlos,
jump in here because I don't want us to get too far ahead. Otherwise, I'll forget to ask. Paul, if you could drop a link to those couple articles you wrote about the future of Go as per your thinking, and also this tool that Ben Johnson wrote, is it open source? Could you share it with us?
Yeah, Ben's in the Slack channel. Ben, share your code.
Ben's hiding now.
I saw him heckling me earlier.
We have to do what we do to everybody. We have to bring him on the show and then put him on the spot on the show.
I think Ben has been on the show.
He has?
Yeah,
I'm sure he has.
Yeah.
Well, 64 episodes. I just can't remember anything past the last 2.
He's been on the show.
Well, that doesn't mean we can't bring him back.
Not that he couldn't be on the show again. Yeah, he'll be the first repeater. But let's go on.
Oh wait, Corey beat me to it. This was so Corey posted in the GoTime FM channel. This is the post that I wrote after. Okay, yeah, it was after GopherCon 2014. This was still pretty early. That GopherCon is where I met Corey and Ben.
That's the first GopherCon. You're OG, original Gopher.
Brian, I have more questions, but go ahead and say what you were going to say.
Oh, I completely forgot. But I think it had to do with
welcome.
Code generation. Yeah, thanks a lot, Carlos. Yeah. As my 2018 resolution is to remember what I was going to say. I think it boiled down to writing a code generator being kind of like the third step of denial in Go. Once you accept that there are no generics, the next thing you do is, all right, how are we going to start generating the stuff we need? Feels like a rite of passage as a mature Go developer.
And I don't think that they're against adding generics. I think that they want to make sure that they're solving for the right use cases and things like that, and that it doesn't make the language more complex.
I'm against generics.
Completely.
Strongly. Yeah, strongly. I love the readability of Go. And I think anything that changes that is really, really bad.
I mean, I guess the question is like, do you think there's a way to add generics, some flavor of it? Let's not, put a Java flavor on it. Do you think the two are antithetically, like they're completely opposed to each other? Like on one side you have generics and on the other side you have readability, and they're just like no way to reconcile the two?
I don't know. All the generics I've seen, and limited exposure to programming languages, but the ones I've seen are not readable in other languages. So I just hate to bring that to Go.
Yeah, I don't want C++ templates.
No.
I don't think anybody wants that.
The Go language team itself, they already dropped sufficient hints that this is not trivial, that there will be major trade-offs to make in regards to, the simplicity of Go versus having that extra functionality.
Yeah, and that's what I'm saying is like, I personally can't say like I want them to add generics because, there's some section of our code base where it was definitely painful to not have them, but most of our code base is actually like we don't really lose anything by not having them. We gain readability.
It's interesting though because when you come from other languages like C++ or Java or things like that, and the complexity sometimes of the way they implement object-oriented programming also is like, right. But then you take a look at the way Go implemented interfaces and kind of like implicitly implementing an interface and composing things rather than kind of explicitly like inheritance and things like that. Like I'm not a language designer and I haven't read a lot of white papers on language design or anything like, but there could be a way to give us something that behaves like generics without being what we know of generics today.
Yeah, I mean, I think the way Go did interfaces is actually brilliant. Before Go, I hadn't really used that. I know Scala has a similar thing, but Scala is like a kitchen sink language in that it has everything thrown into it. So there are like a million ways to program Scala. You can program Scala exactly like you do Java. So coming to Go, like that was actually a real learning experience for me. I never really used that paradigm of the consumer defining the interface, right? And I think that's actually quite powerful. It allows you to do a lot of stuff in code that you otherwise wouldn't be able to do.
Yeah, that is a crazy thing. When I understood what it was, I was thinking, did I understand this correctly? Who had this idea? It was awesome. It's pretty awesome. And so on that note, one question that I have is because you have such a tremendous experience with Go at a large scale, is there anything you would change in the way that you went about developing InfluxDB as far as what you know today about Go or the Go ecosystem?
That's a good question.
Yeah, Go. Well, there are a million things I would change about developing InfluxDB.
Life of a software developer.
Yeah, exactly.
I wrote it yesterday and I hate it.
Yeah, but not so much in terms of design, but in terms of what touches the language and maybe using the standard library or anything like that.
Is a different way to ask that, what lessons did you learn about designing software in Go while you were building it? Is that kind of the same question, Carlos?
Yeah. Yes, it is.
Yeah, I mean, I think part of it is how to organize your project. And honestly, like, I think that's something that we all kind of like fumble around with and learn over time.
Yes.
I can actually point to, which I linked to in a recent blog post I did. Ben Johnson wrote this post that I think is actually very, very good about how to organize a Go project to make it understandable. And I think, we're closer to that in this code base. Like the current InfluxDB code base is actually a complete rewrite of the original InfluxDB, and that's not like a refactor, but it was essentially like a rip and replace rewrite almost, but in the same repo.
So that's probably a good code base to look at for examples of how to organize your code, you'd say?
Well, I think the link that Brian just put up in the channel of Ben's blog post about how to structure applications in Go, I think that is a really good blueprint for how to do it. And I would do more and more like that within the Influx code base. I'm not sure that we have that everywhere. And there's some like weird spots we have where a directory or a package and then the sub packages and stuff like that I'm not totally certain makes sense. But some of this is kind of just like bike shedding, and you can just like everybody can debate about what the right way to organize things is. But yeah.
I've used Ben's post as the almost canonical, like the Bible of how to organize Go code for the last 2 years while I was teaching Go. And, it's never done me wrong. It's such a well thought out process. And yeah, I have nothing but awesome things to say about that post.
Yeah. So I referenced it, and actually I referenced the what I think the Go interface is, what kind of application structures it enables. In this blog post I did recently, where I said it's something I called the decomposable monolith. So I linked the post in the channel. But my idea behind this is like, I know everybody's hot on microservices and all this other stuff now. Obviously, microservices is just like the new service-oriented design, which was the new SOA. Although thankfully we got rid of XML and WSDL and SOAP. But I think for most people building applications, they actually don't benefit from building microservice-based applications. This is like an idea I was kind of playing around with, which is if you're building a new application in Go, is there a way to structure it as a code base where it is a monolith, but then you can later pull out pieces of the monolith as individual services without having to do a massive refactor of your application code base?
Exactly. And that is why I personally don't think that talking about code organization in Go is a waste of time or is a lot of bike shedding, because you can do it in a very purposeful way, which is to accomplish a goal like the one you just said. And I think if you have in mind to package things in a way that, well, what if I want to extract this and put it somewhere else? Or what if I want to share this as a library with other repositories? And if you don't think a little bit why you're organizing code in a certain way, you lose that ability. And that is a great feature that Go has embedded in the language in a way that allows you to write your code into packages. And Bill Kennedy also has a very good post, and I'm trying to find it here on his blog, about how to organize code, and it's a series of 2 or 3 posts.
Mm-hmm.
Yeah, so I like the idea of the decomposable monolith too, and like we've done this before too. Like the beauty of that is like everybody, the holy grail is like having this, horizontally scalable architecture where, just spin up more of these things and the world is great. But people don't realize that with separating things out like that you introduce complexities into the system, and you introduce new ways that your application can break, and that's often not good early on because you're still trying to iterate on the core functionality and get that rock solid, and now you're having to worry about network issues and timeouts and things like that.
Right. Yeah. Most of the time you need to figure out if you're even building the right thing in the first place.
Yeah.
So in our email, kind of talking about you coming on the show, you were talking about kind of speaking of refactoring things, you're changing out the way your hosted solution works. You kind of have like your own custom orchestrator, I believe is what you were mentioning.
Yeah. So our hosted solution is in EC2. And we started developing this in, oh man, I'm probably going to get this wrong. Was this 2016? Yes, 2016. I can't believe it's that long ago. So yeah, this was in like February of 2016. And what we were going to do for this kind of thing was essentially it looks basically like managed database as a service, right? So a customer comes in, they sign up, they'll get new EC2 instances where the InfluxDB like clustered implementation will be deployed on containers with some additional monitoring bits and stuff like that. And then there's a bunch of stuff so that we can deal with, the inevitable EC2 instance restarts, or another thing that we ended up putting in there is being able to like literally clone a custom cluster and take its data and test and play around with it, or say spin up a new cluster with a new version and replicate the traffic, the read-write traffic coming in to both the live cluster and the new test cluster. So because we were doing this in February of 2016, Kubernetes wasn't really mature at that point, since that project's really only like 3.5 years old. So basically what we did was we had pretty simple needs, and we just had a very small team working on it. So they essentially wrote from scratch like a container orchestrator like in Go that also deals with the Amazon APIs and stuff like that. But obviously at this point, like the writing's on the wall. Kubernetes is basically winning the orchestration game. And there's a bunch of like hooks and stuff that you can do within Kubernetes to customize it for your needs. So basically about, I don't know, probably about 3 or 4 months ago, we took a look and we said, okay, one, this single tenant architecture that we have is not really working as we scale up. We run thousands of instances on EC2. And it means that one, like it's a pain to coordinate all of that stuff and to monitor all that stuff, but also like we waste a lot of resources because there are many customers who have very small workloads where a lot of their instances are basically just sitting idle. And this is exactly what cluster orchestration is for, right? So basically like our costs aren't scaling properly with like the number of customers, and we have to manage all these things. And more importantly, if we want to release a feature in the database, we have to do it in the database. We have to test it as extensively as we can. And then we have to try and clone a few customer clusters and replicate the traffic, and then upgrade them. But the thing is, we have to upgrade each of these clusters individually. It's not like a SaaS service where, or a regular, like a SaaS application, usually, if it's something that's operating at scale, either in terms of the complexity or the traffic, you have a number of services underlying it, and you can deploy each of those individually. So it's totally possible to develop and deploy a feature in a SaaS application, for instance, without deploying every single piece of code throughout the thing. And right now, clustered InfluxDB is very much a monolithic application. If you want to develop a new feature, you have to deploy the entire database, which means there's a high risk to deploying code. So basically, as we saw Kubernetes gaining in popularity and really maturing, I thought, well, what if we started to try to think about, for our cloud service and for a database in general, what would it look like if we actually designed it to run on Kubernetes from day one? We took advantage of the primitives that Kubernetes has in terms of being able to schedule things, and we kind of separated out the different kinds of workloads that you have within a database. Like most databases are monolithic things, but they do a bunch of different things. So sometimes, they're just storing a bunch of data. Sometimes they're doing a bunch of query processing for a query that the user is running. Sometimes they're doing some reindexing, or in our case, like compactions on the background data, or because we also are a monitoring platform, we could be doing real-time monitoring and alerting or batch monitoring and alerting. And all these things are trying to make all of that work in a single monolithic application, I think is very, very hard. Whereas if you break each of those out into separate services, you can tune them for the workload that they have to be built for. Then once you pair that up with Kubernetes, you can have it manage, deployment and the shrinking and growing of those services individually. So this year, that's kind of for our cloud thing, that's our big project, is to try to move from this like single tenanted architecture to a multi-tenanted architecture that still has, workload isolation across tenants, but it has the ability to decouple storage from compute, from, processing for ETL or monitoring tasks. And I guess the first part of that that we started doing last year was the development of our new query engine and query language, which is it's open source and up on GitHub. And what we did with that was we actually decoupled the engine and the language from the actual data storage tier. So the nice thing that gets you is it's basically you can deploy new query processors as basically shared nothing application servers that can just be spun up on the fly, which actually, again, is that's actually Kubernetes' sweet spot.
Yeah, and I mean, all the auto scaling and stuff too. Now, are you going to take advantage of sort of like the operator pattern too to deploy these customer?
Yeah, we're already looking into that, actually. And I think one of our guys is actually going to submit a talk to the Cloud Native Con or KubeCon Europe that's coming up. I think it's in early May in Copenhagen. And he's working on operator code for some of these pieces. So I think he's going to try and give a talk on it. So two key things we're looking at is Kubernetes operators, and then also Istio mixers, because there's a bunch of stuff we want to do in a new API tier that mixers seem like the perfect fit for.
Yeah, Istio is freaking incredible.
Yeah,
it's on Fuego.
Yeah, Cloud Native Con in Austin in December could have been called IstioCon.
So there's an interesting kind of crossover here for this show with people who are actually familiar with Kubernetes and that landscape. And then there's also some people who are solely on the Go side. So it might be helpful maybe if we just take a couple minutes to kind of describe what Istio is and kind of the purpose it serves.
Yeah, so Istio is a project built by Google, written in Go. It is paired up with, it's what they call a control plane. It's paired up with Envoy proxy. So Envoy, unfortunately, like to describe Istio, you have to go down this rabbit hole. Envoy is basically a proxy, but it's also something for building what Matt Klein, its creator, calls like a service mesh. So basically, Envoy is written in C++. It was developed at Lyft by Matt Klein, a team of other people, but now they have contributors from many organizations. It's part of the CNCF at this stage, as well as and Istio is as well. So they're part of, the CNCF, which overlooks Kubernetes and Prometheus and a bunch of other projects. So Envoy is basically a sidecar that you can deploy with your containers to act as a proxy, but also a service mesh to do it can integrate with service discovery and do all this stuff, so it can route traffic from one service to another. It can do things like rate limiting and all sorts of other stuff. So Istio stacks on top of Envoy. So if you're using Istio, you're using Envoy. And it stacks on top of Envoy to work as like a control plane, which is a bit more programmable. So you can build in all sorts of custom features. I'm not an expert on either at this point, so I'm not really qualified to give a much better answer than that. But yeah.
Yeah, and it's really interesting because it allows you to kind of inject your way in between kind of container to container communication. You can like Paul said, you can kind of do rate limiting and stuff, but you can also set rules as to which pods are allowed to talk to which other pods, or even outbound or inbound traffic to them. You can do stuff like inject headers. So if you want to just kind of be able to quickly add distributed tracing to your application, that's kind of a quick way to do that. It's just super, super powerful.
Yeah. By the way, the distributed tracing stuff is actually Envoy and Istio are actually one of the few ways that I think tracing will take off, because I think the burden to a developer to actually implement tracing within their own application code is way too high. I think having Envoy and Istio in front makes it so that you can get tracing kind of out of the box without putting this huge burden on the developer to get it done.
And I think it's interesting too, because then the more you use the tracing, because you kind of got it for free, right? The more it encourages you to add new metrics to the distributed tracing to help do that. But most people aren't highly motivated to have to do the from scratch implementation into all of their services.
I wanted to ask a question that I always like to ask anyone who comes on the show that is heading a company or a big team, and that is about hiring. And I wonder, how is hiring Go developers going for you? What do you look for? Does it matter if the person knows Go or not? And do you recommend that people who want to work on anything that is made in Go, that they go and learn Go beforehand?
So,
And anything else you want to share about that?
yeah, sure. So, I mean, I think it's a mixed bag for hiring Go developers. So the thing is, like, we have a number of different projects, and some of them they like, even though they're all like written in Go on some level, they require vastly different skill sets. So, for example, our user interface chronograph is, there's a bunch of Go code, and there's this massive, like, single page React JavaScript application. So, but the Go code in that is very, very different than the Go code you'd find, say, in the storage engine or the query engine of the database. So both are Go, but I don't feel like Go developers are kind of interchangeable. So I can just say, oh yeah, go write the database, or you take a database person and say, go write these web APIs or whatever. So generally, for the database, what we try to do is filter based on a skill set that matches up with that, whether they have experience in Go or not. Although many of our database developers had experience in Go already coming into it, although not all of them did. So for that, it was basically like, Go is an easy language to learn. That's one of the things I love about it. Like, you can point somebody at the spec and the basic documentation, and they can be productive within a few days. Particularly if you have like code review and stuff like that, that'll let them as part of your process, because then they can just start doing pull requests and like pick up idioms along the way, and have the developers who are already very familiar with Go and the idioms push them in the right direction. So I would say, like, actually for most of our stuff, it really depends. Like, we don't necessarily require Go experience just because of the fact that you can pick it up so quickly. I think some of the other stuff around doing performance optimization and using the profiling tools and that kind of stuff is more advanced Go stuff. So if we were trying to hire for one of those roles, we would filter for that kind of experience. So it'd definitely be somebody who knows Go, who has experience doing those things. But those those roles are kind of few and far between. I think for the most part, it's just, smart developers who are, at the very least, are excited to work in the language. I wouldn't want to hire somebody who didn't know anything about Go, just because it's entirely possible that you could get somebody coming from another language who uses Go who just absolutely hates it. And then at that point, like, if you've already hired them, that's it's not a good situation for either of you. So I think for hiring, we benefited for sure from having open source bits all over the place. We've hired a number of people from like our contributor community. Like, we've seen commits and actually reached out to them and said, hey, your code looks great. We're really interested to talk to you and see if you'd be interested in coming to work with us. That's nice, but that doesn't really scale. And like I said, we kind of have to double our engineering team in 12 months. So at this point, it's, we use that, we use job boards, we use recruiters. And I feel like for some of these roles, we're definitely going to be pulling in people who aren't familiar with Go and training them up on the job.
This was super informative, Paul. Thanks.
Yeah.
I think I'm forget what time we started, but I think we're running shorter on time. Do we want to jump into some projects and news before we do Free Software Friday?
Yes.
There is
All
a
right.
huge list there. Oh my God.
We haven't been on the show for weeks.
Okay.
So much cool stuff to talk about.
So I'll start off with a new project that I saw that I didn't play with yet, but man, does it look cool. It's called Grumble, and it's at github.com/desertbit/grumble. And it's an automatic CLI and shell tool. The API for it looks almost like an exact clone of Cobra from Steve Francia's SPF13 Cobra library. However, it also has a shell. So instead of just being able to do command lines, you can drop into a shell and have an interactive shell that works with your application. So I really want to play with that because that looks kind of fun.
This is cool. Like a REPL kind of thing?
Exactly.
Nice.
Sorry, I missed the link. Can you post it in the channel?
Absolutely.
And so while we were at Cloud Native Con and KubeCon, one of the things I hadn't heard of before was OpenFast, which is Open Functions as a Service, which is kind of implementing serverless on top of Kubernetes. And what's the URL for that? It's
OpenFast, github.com/openfast/fast.
Openfast.com. Yeah, the regular website is openfaas.com too.
Okay.
And I think that's really cool. And it's one of the things I'm most excited about for Kubernetes now that we've kind of accepted how awesome Kubernetes is as like a container orchestration platform. Like now it's starting to catch on like the modularity of the system and how kind of each of the components, the schedulers and things like that are all implemented separately and you can build your own. And I'm really looking forward to kind of the more creative use cases that we build and abstractions on top of Kubernetes.
Well, speaking of containers, I didn't put the link in here, but I've played with Alibaba's Pouch, which is pretty slick. That's from the Alibaba team. I believe that's out of China. Fast and efficient container engine that vaguely competes with Docker. Really cool stuff, and lots of good technology decisions in here that I think are informed by their huge traffic. So Alibaba's Pouch is something to check out if you're interested in learning about how to do containers at scale.
I dropped that link in there. Like they're actually a really huge user of containers. And I know there's some stuff built in there around security and using like Hyper-V and stuff. But one of the interesting things that I saw about it was actually in the way they distribute images. It's done using peer-to-peer instead of a central repository server, which it should make it much faster to have nodes pick up images.
Yeah,
because that always seems to be the slow point, right? Like another instance goes to start up, or if it fails over to another node, but the image hasn't been pulled yet, and then there's kind of like that lag waiting for it to get there. Whereas if it just pulled it from another node in the cluster that has it.
Yeah, the documentation in that GitHub repository for Pouch is well worth your time to sit down and read through it. I did it a couple of days ago and I wasn't disappointed. There's lots of good stuff in there.
All right, what else do we have?
I've got one.
Awesome.
Okay, cool.
I don't know if it's new. Well, I just heard about it, I guess, a month and a half ago. So Google has this effort to try and combine in an open source framework metrics and distributed tracing. So they wanted to build it out as like a standard and stuff like this. So the project is called Open Census, and they have code like a Go library up already on GitHub. So it's github.com/census CENSUS -instrumentation /open census -go, which I will post in the channel. So I think it's interesting because they have their monitoring product called Stackdriver, but they are trying to still like push out open source tooling, at least on the client side, and they're trying to basically build this standard tooling platform on the client side so that you could actually use. And what they're hoping is that the other cloud providers and the other monitoring providers will actually implement these protocols so that you could use this library and actually use many different monitoring providers.
Interesting. So does this compete with open tracing? Is it a different spec or same purview?
I'm not sure if it actually implements the open tracing spec, because open tracing isn't really an implementation so much as a specification of that, how that works. So it could actually just be, I don't know, it could just be another open tracing implementation, although maybe not, because they have some weird stuff in Stackdriver because it's all based on their time series database called Monarch. So I think they may have some stuff in here that's specific to that, but.
Interesting. Now I got to go play with this. You found my weakness.
That's the problem. Like this whole space and landscape is just exploding, and it's too hard to keep up with everything that's being created and the advancements.
Yeah. Okay. So I'm looking at it. So they do actually support already the Prometheus exposition format and the OpenZipkin.
Oh, they do Azure App Insights too. Look at that. Hey. All right. We know what I'm doing tonight.
So another cool post, if you happen to be newer to Go and come from a language that may not have pointers already, Dave Cheney's blog, and all of the stuff we're talking about, we will drop links in the show notes. Dave Cheney's blog has a great post titled Understanding Go Pointers in Less Than 800 Words or Your Money Back. So that's actually a really good resource if you kind of want to understand how variables work and pointers and things like that, and don't necessarily come from C or something else that supports pointers.
Boy, was that me. When I first, who was I having this conversation with the other day? I was helping somebody learn Go, and they're like, "Well, what do you do about when it tells you, it expected this, but it got that?" And I said, "Just change it from a ampersand to a star." They're like, "What?" I said, "It doesn't matter why, just do that until you understand." And that's how I got through Go the first year, because I had no clue what pointers were. I came from Ruby. No clue.
It's always one or the other.
That's right.
just two choices. See if one doesn't work, the other will.
Change it and recompile. See what happens.
I mean, it does have its implications, right? Especially when you talk about like interfaces and things like that, like whether it can actually change the value that's embedded within the interface that's being passed and things like that.
Of course, I understand that, Eric. Just saying, when you got to get through it, sometimes you just need to flip a bit and recompile.
So another cool project that I found was called Pixel, and it's a 2D game library in Go, and I'm really interested to see kind of what comes from that. I really love when people have like creative use cases like outside of just writing like microservices in Go.
Oh wow, can you do like platform games with it?
I don't think it supports that. I think it's only
Never mind. I just clicked on the site and it says platform games, and it's got a little gopher jumping off of platforms. Oh my God. That's it. We're writing games for the rest of the day. Thanks a lot for coming, Paul. We got to go.
What are the little things that we have? The pocket chips? I totally need this on the pocket chip.
Right? Oh my God. Pocket chip is a tiny little Linux computer, by the way, with its own screen and keyboard. Not too much different. If you're as old as me, what were those little pocket devices we had that were, handspring trios, Palm Pilots. It's about that size, a little bit bigger, but those were the days. I just dated myself.
Yeah,
Sorry.
they are on getchip.com if you're interested. And there should be a link that says Pocket Chip. But they're fairly inexpensive. I think they're like 50 or $60. And they've got like a keyboard on them and they run full Linux and you can install Go on there. And they've got some pinouts and stuff like that too for doing like GPIO. So it makes for kind of a fun hacking project. Outside of using like Arduino, you can actually do Go.
We're all over the place today.
Right. So, and it's always fun stuff, especially coming out of the holidays. Like I've got a Sphero now that I need to play with GoBot with.
Oh, nice.
Yeah. So, time for Free Software Friday. Who wants to go first?
Me.
All right, Carlicia, let's hear it.
So this week was the first time that I had an if error loop inside another if error loop. And I sort of wanted to report both errors. If there was an error in both loops, I wanted to wait for the second one and then report both. So I was thinking, well, there has to be an easy way like a neat way to do this. And then I found this package from HashiCorp called Go Multi-Error. I didn't know this package before. It's very simple, lets you do exactly that. And I thought it was pretty neat. It just appends one error to the other. And you can have a bunch of errors just appended, just like you append to a list. I thought it was neat.
Does the multi-error present itself as a single error with a underlying slice of errors with it, so you can still use it in place of something that expects an error?
It will present itself as one error.
Well, that's cool.
Yeah, not a list of errors, just one error.
But then you could type assert it and get the underlying errors too?
I did not test that.
Okay, I'll go check it out. That sounds pretty sick.
I think it will be it's just one string of all the errors, maybe separated by some separator, maybe a dot.
Cool. All right, I'll go next. I found the coolest. I love hacky, crazy things. This application called LX Run Offline. So I've been using Windows as a development environment for many months now, along with my Mac and my Linux machines. And Windows has the WSL, the Windows subsystem for Linux. And previously, you were only able to install one installation, which was Ubuntu. And then with the Fall Creators Update, they brought two more. So you could have OpenSUSE, Ubuntu, and not Fedora, but a different one. I can't remember which. So you could have 3 installations, but that was it. You're limited to those 3. So this LX Run Offline app allows you to create any number of installations of WSL, each with their own backing file system, which means I basically can create a sandbox for every app I want to build with very little disk overhead and no performance overhead. So I used it and I wrote a blog post about it over the holidays about how I created a new development environment using LX Run Offline for sandboxing all of my code. And it was a ton of fun.
I still need to play in the Windows and Windows subsystem Linux world.
Where do you work?
I hide in the Linux closet.
Poor Eric.
I mean, especially with Windows subsystem for Linux, like Windows has gotten a lot more intriguing to me. And I'm liking my Mac hardware less and less, but I'm still a Linux person at heart.
Yeah, we could have a series of shows about operating systems, and I still would not run out of things to say about all 3 of them. All right. Any other Free Software Friday shout outs?
Paul, do you have anything?
Yeah,
that
I'll do one.
Influx Data? Yeah.
Yeah, I'll do one. But unfortunately, it's not specifically a Go one. So I will give a shout out to Wes McKinney, who he built a lot of stuff. Pandas is what he's most famous for, but Arrow is a project, Apache Arrow is a project that he is putting a lot of work into that I think is particularly interesting. It's basically a data format that can be represented in memory the same way. So ideally, it can be represented cross language in the same exact format. And there are a bunch of things that it's designed to do. Like he's done a lot of data processing work and pandas and bigger data work and stuff like that. And the whole thesis behind Arrow is, frequently when you're moving data around, you actually have to copy the data in memory frequently, and then you have to, marshal it between different kinds of formats, and you actually waste a lot of processing power and bandwidth doing all of these things. So the idea behind Arrow is that you can actually achieve much better efficiencies through zero copy methods and without having to marshal things into different formats. So the idea is Arrow would be the substrate, the data representation for many different data processing libraries or machine learning libraries or stuff like that. So we are actually looking at it as basically a data interchange format for basically our data tier and our query processing tier, and then also exposing that out to clients. So basically we can process data across the network and all this other stuff without having to waste a bunch of time, say serializing it into protobufs and then pulling it back out and representing it as these ghost trucks and all this other stuff.
I read through that Arrow's website the other day, and it looked really interesting, looked fascinating, actually, the way they store the data, almost pivoted for faster retrieval. It was a good read.
Yeah, and Wes has a really good blog post about, or either a blog post or a talk, or probably both, about some of the motivations behind the project and what are the specific reasons for developing it.
Just so many cool things and nowhere near enough time.
Agreed. So with the holiday break and not doing much development, I don't have one offhand. So I'm going to give a huge shout out to Ron Evans and all the folks at Hybrid Group, really, for GoBot, for doing the GoBot room at GopherCon so people can come and freely play with Go on hardware. But for people who are from other circles, they also have Cylon.js and R2, which is basically like GoBot, but in Ruby and JavaScript. And GoCV, which is another thing I'm going to play with, because I'm convinced I'm going to use the webcam on my laptop with GoCV and GoBot to make my Sphero find its way around an environment or learn to bowl or something. If you have ideas for how to incorporate OpenCV and controlling a little robotic ball to roll around, I'm open for ideas, but I want to marry them somehow.
Awesome.
All right. So I think we're a little over time, but with that, I want to thank everybody for being on the show, especially a huge thank you to Paul for coming on the show and kicking off the new year in style.
Yeah, thank you.
And definitely thank you to everybody who's listening. You can find us at GoTime FM on Twitter. We are gotime.fm on the interwebs. If you want to be on the show, have suggestions for topics or guests, you can file an issue on our GitHub, which is github.com/gotimefm/ping. And with the holiday break, if I didn't forget anything, that's it. See you next week, everybody. Oh, wait.
We forgot to mention that today's show is sponsored by the letter G and the number 12. Thanks.
Have you been watching a lot of PBS? All right, bye, everybody. We'll see you next week.
Bye-bye.
Bye. This was fun.
Bye.
All right, that's it for this episode of Go Time. Tune in live on Thursdays at 3 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. Follow us on Twitter. We're at GoTimeFM. Special thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. Also, Linode. We host everything we do on Linode servers.
head to linode.com/changelog. Go Time is edited by Jonathan Youngblood, and the theme music for Go Time is produced by the mysterious Breakmaster Cylinder. We'll see you again next week. Thanks for listening.